Hi everyone. Today we are going to talk about 12.5 analyzing data sets second part. So we are going to find the number or percentage of data within 1 or 2 standard deviation of the mean. So how many data are in the range of 1 standard deviation or 2 standard deviations in range, okay, from the mean. Let's see. So last time we learned that standard deviation is a number used to tell how measurements for each data scores for a group are spread out, how they are spread out from the mean or average or expected value. So when we get the standard deviation, if the standard deviation is low, it means that most of the numbers are close to the average, right? But if the standard deviation is high, it means that the numbers are more spread out. So that we learned. Now, today, so let's say you have a data like this time we have a frequency table, right? Each data has a frequency. It means the scores like 18, one person got 18, 7 people got 23. So you can put this data like not this way, 18, 23, 23, 23, 7 times, and 30, 30, 27, 10 times, 30, 12 times. So like this, right? But that's too much to put the one data like a, in like in a row. So it's better to make a frequency table like this, right? So one person for 18, 7 people 23. It's better to look, right? And it's better, it's more organized. So that's how we use this frequency table. Then how do we use this frequency table to get the mean, standard deviation, and all the data, right? N is a number of data. How many are they? You should add them all and figure out how many. But when you put this in the calculator, you can just find out how many are there too. So how do you do it? There's a step. First, stat, edit. Now this time, you should put the first data, the scores in the L1 and the frequency in L2, right? And then go to the second again, stat, first variable stat, and then calculate. That's it. Now I think you can do it by yourself. But let's do it together. We'll go to the calculator and let's follow the step. Stat, edit. So where's edit here, right? Number one is edit. So you click. Oh, I already entered all the data in L1, all the data in L2, the frequency. Good. You put all the data by yourself like this. Then what do? You do the second step. Stat, go to the stat again, right? Go to the stat, and then where's the first variable? First variable stat, where is it? Now go to the next one, calculation here. How do you move? Arrow. Then do you see the first variable stat? So choose that one. Now here is more very important. List L1, right? The scores are in L1. But what is the second one? Frequency list. The frequency is in L2, right? So you should choose L2 here. Usually it was empty. You should choose L2. The second 2 is L2, right? Then you will get that. So enter and you put the L2 here and calculate. Then you get the result you need. The mean is 33.99, sum is a 2753, And here standard population population standard deviation is 6.39. How many scores are there? 81. So 81 people's score are in the table, right? So you got this in the calculator. Let's move like this, right? But today's question is, what is it? Find one standard deviation range from the mean. So your mean is 33.99 is, let's say it's here, your mean is here. And one standard deviation is 6.39, right? Standard deviation 6.39. So if this is a low, it means scores are very close to each other. So if it is a high, they are far away, the score values. But 6.39 is not very big, right? If the range is big, it could be standard deviation could be higher than like a 10 or 20, something like that. Then it's better. But 6.39 is depending on. So you have only one data set, so we cannot compare with something the other one. But now mean is here, 33.99. Now one standard deviation, the range, one standard deviation range from the mean, which means from the mean you can go further by adding standard deviation from here to here. So you add a 6.39, that is the highest value. And if you also, not only the bigger number, one standard deviation, but also one standard deviation, smaller number also is in the range, right? So one standard deviation, smaller one. So from the mean, you subtract the 6.39, it'll be here. So we want to see all the data between this value and this value. So what is this? If you subtract, so 33.99 minus 6.39, this, and then this one is 33.99 plus 6.39. Make sense? And then if you get it, this is 27.6, this is 40.38. So you write down like this. So find one population standard deviation range from the mean, which means you want to find out how many data, all the data between 27.6 and 40.38. So how many data are between here? Look at the table. 27 doesn't belong here, right? 27 is here. So from 30, you start from 30 and then up to 40.38. 42 is bigger than here, so it's not here. So from 30, 35, 36, these data are in the one standard deviation range from the mean. You understand? How many data are there? 30 is 12, 35 is 19, 36 is 13. So 12, 19, 13. If you add them all, 31 plus 13 is 44 data, right? How many data? 44 data. And how many, what percent is it? How do you get the percentage? 44 data from entire data is, we knew that n was 81, right? So divided by 81, total is 81. So 0.543, which is 54.3% of data is in one standard deviation range from the mean. How many percent in this data? 54.3%, a little bit more than half of all the data is within one standard deviation range. That's the meaning. You understand, right? Sometimes we want to know two standard deviation range. Like, so I want you to think about by yourself. So how many data in the two standard deviation? Now you know what to do, right? You subtract from the mean subject 2 times of standard deviation. You can get the value here. And then also here, 2 standard deviation you add. So can you do it by yourself? Okay, let's stop here.